Hello AP Stats students. Today we're going to be reviewing Inference for Categorical data, which is proportions. It's going to be Unit 6 and it's going to cover chapters 19 through 22, and some of the topics in this, just to recap, are like confidence intervals, margin of error, hypothesis tests, type 1 and 2 errors, and then 1 sample proportions and 2 sample proportions. But today it's mostly going to be focused on hypothesis test and 2 sample proportions, but there will still be some of everything else. So the difference between a confidence interval and a hypothesis test. So a confidence interval is going to be an estimate of where a true proportion of an event or a claim lies through a range or an interval using an observed proportion. And then a hypothesis test, it tests the validity or the truth of a claim about a population parameter using an observed statistic. If we remember, the formula for confidence interval is going to be the estimate plus or minus the margin of error or ME. And this formula, you can find it on page 437 in the textbook. And then margin of error is going to be on page 442. Page. And then, to be more specific, confidence interval. So the estimate is going to be your statistic. Or your p-hats, plus or minus, and then the formula for margin of error is going to be your z-score times your standard error. Okay, and then standard error, you can find it on page 433 in the textbook. And we're going to interpret the confidence interval in context using the phrases from the sheet that Mr. Vercow gave us. It's going to be number 6. We're going to jump over to hypothesis test. And that's the hypothesis test today. We're going to be comparing 2 proportions. And this is going to start on page 498 in the textbook. Alright, and then so the 2 proportions is going to be similar to the 1 proportions in the hypothesis test. So the steps are all going to be pretty similar. We're going to have a hypothesis in which we have to label our P, and then our null hypothesis and our alternate hypothesis. And then next is going to be plan and model. So this is where we're going to label and check assumptions. So for proportions, we're going to be using certain. And then, so this is going to be the success failure conditions. This is going to be independence, randomization, and then the 10% is going to be if the population we're given is less than or equal to 10% of the whole population. Continuing in the plan and model, after this is going to be proceed with caution, which just means that we've checked all the assumptions and that we're just going to continue with our test. And then we have to label the tails, and then our test, which is in this case 2 prop z test. Oh, and then the significance level, and we're just going to be using the 0.05 or the 5%. Okay, and then after the plan and model is going to be the mechanics, which in this case is just going to be our calculator commands. So for the two proportions test, you're going to go stat, then test, and then we're going to pick the two prop z test. And then finally, after we're done with that, we're just going to write a conclusion, which will either fail to reject or reject the null hypothesis. And again, it's going to be in that formula sheet that Mr. Foucault gave us. And it's going to be number 9, decision and significance test. This is going to be the overall steps for our hypothesis test. Okay, so the example that I'm going to be showing from a previous AP test is going to be from the 2004 FRQ, Form B, and then it's going to be number 6, Part A. So if you pull it up, it's going to read, in order to monitor the populations of birds of a particular species on 2 islands, the following procedure was implemented. Researchers captured an initial sample of 200 birds of the species on Island A. They attached leg bands to each of the birds and then released the birds. Similarly, a sample of 250 birds of the same species on Island B was captured, banded, and released. Sufficient time was allowed for the birds to return to their normal routine and location. Subsequent samples of birds of the species of interest were then taken from each island. The number of birds captured and the number of birds with leg bands recorded are below. The results are summarized in the following table. And then it asks, assume that both the initial sample and the subsequent samples were taken on each island are random samples from populations of birds. And then, so question A asks, do the data from the subsequent samples indicate that there's a difference in proportions of the banded birds on these 2 islands? Give statistical evidence to support your answer. So just from the question, this is going to be all the given information that we can pull out. So from Island A, there were 12 birds in the subsequent sample that were caught with bands, and then there was 180 caught overall, so our p-hat is going to be 12 out of 180. Then again for Island B, there was 35 that were caught with leg bands, 220 were caught overall, so then our p-hat is going to be 35 over 220. So for our hypothesis test, we're going to start off with the hypothesis. We have to label our PA and PB. PA is going to be the true proportion of banded birds caught from Island A. And our PB is going to be the true proportion of banded birds caught from Island B. So then next we're going to do our null hypothesis. So the null hypothesis is going to say, like, we're going to assume that there's no change. So we're going to say PA equals PB. Or you could also do PA minus PB will equal 0. And then for our alternate, it could be PA is less than, greater than, or not equal to PB. And the reason that this case it's going to be not equal to is because in the question it asks if there is a difference in the proportions. So it doesn't specify if it's less than or greater than, just if there's a difference. So it's going to be not equal to. And then the or PA minus PB is not equal to 0. Okay, so then that's going to conclude our hypothesis. Okay, so our next step is going to be our plan and model. Oops, there we go. So we're going to check for our assumptions first. We have our certain. So for the first one, success failure conditions, we want to make sure that our NP hats and our NQ hats are both greater than 10. So for Island A, we have N n, lowercase n, a times p hat of a equals, and again from our given information, our n is going to be 180, and our p hat was 12 out of 180, so we just cancel out, we get 12, and 12 is greater than or equal to 10, so that's checked. And then for our lowercase q hat of a, so q is just going to be the opposite of p. We have the same population, 180, and the opposite of 12 out of 180 is going to be 168 out of 180. Again, we cancel out and we get 168 is greater than or equal to 10. So that's good. And then, so this is island A. Moving on to island B, again, we have NB times P hat B equals, our N was 220 times P hat is 35 out of 220. Cancel, cancel, equals 35. 35 is greater than or equal to 10. And then lastly, we have NB times QB equals 220 times 35. So 220 minus 35 equals 185 out of 220. Cancel, cancel, equals 185 greater than 10. Okay, so that passes. And for independence, we are going to assume that the two populations, population A and population B, are independent of each other. We assume that the island A birds are independent of island B birds. And then for this, it was given, they told us that they were random samples. The samples, and that was given. And lastly, 10%. We assume 180 is less than or equal to 10% of the population. And then we assume 220 is less than or equal to 10% of the population. Okay, so then that's going to be our certain. So now that we have checked our assumptions, we're going to proceed with caution. We have to state our tails. And since this is not equal to, we're going to have two tails. So on our normal model, this would be shaded and this would be shaded. Kind of ugly. Oops. And then we have our significance level, and we're going to just assume it's 0.05. And then our test, and we're going to be using 2 prop C tests. Okay, so that's it for the plan and model. Next is going to be the mechanics. So the mechanics is just going to be the calculator commands. So our calculator commands, we're going to go to stat, test, and then 2 prop C tests. So on the calculator, we have stat test, 2 prop C tests. It's option number 6. And then we're just going to input all of the values that we already have. So for x1, we're going to input 12 from our island A. Our population was 180. And then for x2, it was 35, population 220. And then we're going to pick not equal to, and then calculate. So really quick, just writing it out. x1 equals 12, and p1 does not equal to p2. So here we get a z score of negative 2.885. Negative 2.85, but we can round it to 86. And then a p-value of 0.00429. Okay, so that's it for the mechanics, and then lastly is just going to be our conclusion. Let's switch colors. Okay, so for our conclusion, since the p-value is less than our significance level of 0.05, we are going to reject the null hypothesis. Since the p-value of 0.00429 is smaller than the significance level of 0.05, we reject the HO. So we have convincing evidence that the proportion of banded birds on the 2 islands are not the same. Okay, and then that's pretty much the end of the hypothesis test. Oh, one more thing. So for the touching on another topic in this unit is going to be the type 1, type 2 errors. So for this one, we could draw our box. And this one is going to be the null is true, null is false, reject, HO, fail to reject. So if the null hypothesis is true, we would fail to reject. So this one is the happy face. And if it's false, we would reject it. So this one's the happy face. So if it's true and we reject it, that is a type 1 error. And if it's false and we fail to reject it, that's going to be a type 2. And in this case, since we rejected, if we had made a mistake somewhere, it would be a type 1 error. And then that's going to be the end of our sample proportions video.